Good day, everybody. You are welcome to the new episode of today's class. Today, we shall be discussing redox reaction. Redox reaction. Now, redox reaction is a jointed word. It says reduction, oxidation, reaction. Reduction can have like 6 definition, and oxidation also has like the 6 definition. So a redox reaction is a kind of reaction that involves the transfer of electrons from one chemical substance to another. Mostly reduction involves the addition of electron, and oxidation is opposite of that. So but we are going to take them one by one so that we shall understand the topic into details. Then after that, we are going to discuss oxidizing and reducing agents. Let's start. Let's start with oxidation. Oxidation can be defined in 6 ways. 1. Oxidation is defined as addition of oxygen. Addition of oxygen. That is one definition of oxygen. Take for example, adding oxygen to a substance, magnesium plus oxygen, giving us magnesium oxide. Let's balance the equation. 1 magnesium is here, so we put 2 here, 2 will be here. So anytime we add oxygen to a substance, it is termed as oxidation. Number 2, oxidation can also be defined as removal of hydrogen. Anytime hydrogen is removed from a substance, we term it as oxidation. For example, hydrogen sulfide plus chlorine, giving us hydrogen chloride plus sulfur. Here, this is the substance that has the hydrogen, and here that hydrogen has been removed. In this case, oxidation has occurred to hydrogen sulfide. So number 3, the third way, we can define oxidation as removal of non-metal. We can define it as addition of non-metal. Addition of non-metal. When we add non-metal to a substance, it is termed as oxidation. Take for example, iron is a metal. We add sulfur to it. That is non-metal. So giving us iron sulfide. This is oxidation. So number 4, it can also be defined as removal of metal. Removal of metal. Anytime metal is removed from a substance, it is termed as oxidation. Let's use this reaction: potassium iodide plus hydrogen peroxide, giving us potassium hydroxide plus iodine. We have 1 here, 2 hydrogens. Okay, we have it here, 2 oxygen. Correct. Then potassium has become 2. The equation is balanced. Now, this is the metal. That metal has been removed here now. So removal of metal is termed as oxidation. Number 5, the 5th way we can define it. It can be defined as loss of electron. Loss of electron, loss of electrons. It can be defined as that, loss of electron. And we use one of the equation we have used before. We can use it, loss of electron. Let's see, if we use H2S plus Cl2 here, we want to see plus sulfur, which one has lost electron. In our previous episode, we have taught us how we are going to determine the oxidation number of a compound. This one now, hydrogen is +1, so we want to see the oxidation number of hydrogen here. We have 2, that is +2, and hydrogen sulfide will be -2 if we calculate it very well. Let me quickly do that for those who might have forgotten. We don't know for sulfur, but we know hydrogen to be +1, but we have 2 of it here, so +2 plus sulfur is equal to 0. So sulfur is equals to -2. That is why we have -2 for sulfur. So chlorine will be 0 here, because the oxidation number of any element in its elemental state will be 0. Here hydrogen is +1, chlorine is -1, and here sulfur is 0. Let's see which of them has lost electron. Here hydrogen is +2, sulfur is -2. Sulfur has gained 2 electrons here, but when it comes to this side, it has lost that 2 electron. Can we see? It has lost that 2 electron. Okay, let's balance it. It seems that the question is not even balanced, because we have 2 hydrogen here. 2 should be here too, and chlorine is 2 here, is 2 here now, is 2, sulfur is 2. Okay, it's balanced here. So that means hydrogen will be plus 2 here, and chlorine will be -2. Okay, so sulfur, which has gained electron before, -2, has lost it here now. That is loss of electron. Oxidation has occurred. So we are going to need this equation again when we are discussing oxidizing and reducing agents. So now the sixth way we can define it is increase in oxidation number. Increase in oxidation number. Take for example this magnesium. If magnesium loses an electron now, this is oxidation, loss of electron, as we have seen here, loss of electron. But this one is taking oxidation state of 0, and this one is taking oxidation state of +2. If oxidation occur in chemistry, plus means losing. So, and it will increase if it is plus. So from 0 to 2, that means it's increasing. So if the number is increasing on the oxidation state, that shows the oxidation, it is oxidation. The increase in number implies oxidation in chemistry. That is that about oxidation. Now let's take a look at reduction. Reduction, which is opposite of oxidation. Reduction is opposite of addition. We will take them one by one. In oxidation is addition of oxygen, but here it is removal of oxygen. I said it is opposite of oxidation. So removal of oxygen. we remove here now. Let's use copper oxide plus carbon, giving us ordinary copper plus carbon oxide. This oxygen has been removed, so it doesn't have it again. That is reduction. The second way, in oxidation is removal of hydrogen, but reduction is addition of hydrogen. Addition of hydrogen. They are vice versa. Addition of hydrogen. So let's use chlorine plus hydrogen, giving us HCl, that is 2 HCl. Adding hydrogen to substance is reduction. Number 3, oxidation is addition of non-metal, but reduction is opposite of that. Reduction is removal of non-metal. Removal of non-metal. Removal of non-metal. We can use any equation to do that. Number 4 now. In oxidation, removal of metal is oxidation, but here addition of metal is oxidation. Addition of metal. There are so many equations we can use. So far we can recognize metal from non-metal. Addition of metal, mercury chloride plus mercury, and we had another mercury. Don't forget mercury is a liquid metal, so we have H2AgCl. We have added this mercury to this now here, so we are having 2 mercury here. It's addition of metal. Number 5, decrease in oxidation. Decrease in oxidation states or oxidation number, is opposite of that oxidation. Decrease here. Let's use this. If chlorine Cl, if it gains an electron to Cl, it has gained an electron here. So oxidation state of chlorine here is 0, and it is minus here. Minus in terms of electron is addition of electron. It has gained, but in mathematics is decrease. So if a substance gains an electron, its number is going to decrease. So it is from 0 to -2. So decrease in oxidation states or oxidation number is termed as reduction. Number 6, that is opposite of that of oxidation. I think we are done. Which one? Okay, we have missed one that will make it to be 6. One of them is oxidation is loss of electron, but reduction is gain of electron. That is the main definition of GOGO. Gaining of electron, like zinc ion plus it has lost 2 electron here, it gains it back to give us zinc. Gaining of electron is oxidation, is reduction. Now let's go through oxidizing and reducing agents. Oxidizing and reducing agents. This is one of the aspects that the student used to get confused. By definition, oxidizing agent is the substance. Oxidizing agent is the substance, that gains electron, and is thereby reduced to a low valency state. That is oxidizing agents. Let me now explain. That means agents of oxidation. In terms of electron, oxidation is loss of electron. So if a substance is working towards losing of electron, that means it will cause a substance to lose electron. Oxidation will always cause a substance to lose electron, oxidizing agent. So it will be working towards ensuring oxidation occur. So it will be an agent of oxidation. So it will always cause another substance to lose electron. That is oxidizing agent. And the reducing agents, on the other hand, reducing agents is the substance that loses electron and is thereby oxidized. Is thereby oxidized. Is thereby oxidized to a higher valency state. We are going to use one equation to explain this one better. So reducing agents, it will be working towards reduction. That means it will be giving out electron to another substance to make sure that a substance gets or gains an electron. And if a substance gains an electron, that is reduction. So a reducing agent will be working to make sure that reduction occur. But the funny thing is this: anytime an electron is loose, anytime a substance loses an electron, there must be a substance that will gain it. And anytime a substance gains an electron, another substance has lose an electron, and that is what makes a reduction. There is no way oxidation can occur and reduction will not occur. Take for example, we define oxidizing agent as a substance that gains electron because it is the one that caused that oxidation. So when it has removed an electron from another substance, it is the one that will gains it. So it will do its own work by making sure that another substance gets oxidized. After doing that, it has removed an electron from a substance. It is the one that will now hold that electron. If it has had that electron to itself, it serves as gain another electron, and gaining of electron is reduction. That is why in its definition we have said it is the substance that gains electron. If substance gain electron, that substance has reduced. So at the end of the day, an oxidizing agent will get reduced because it is the one that will keep the electron that another substance has lose, although it is the one that causes that loss of electron. But when it gains that electron, itself has gains an electron, and thereby it has reduced. And vice versa, reducing agent. When a reducing agent causes another substance to gain an electron, it is the one that give out that electron. When you give out an electron, you lose it. That means you get oxidized at the end of the day. So a reducing agent causes another substance to gain an electron, but itself is losing. So thereby, it is oxidized. Reducing agent gets oxidized at the end of the day, and oxidizing agent gets reduced at the end of the day. Okay, to make us understand this better, let's use the equation we have used before. We used hydrogen sulfide plus chlorine to give us 2HCl plus sulfur. The oxidation state we have calculated before. We said this one is +2 and this one is -2. This one is 0, and we have +2 here. We have -2, and this is 0. Okay, let's look at it. What happens to hydrogen? Hydrogen, nothing happens. Hydrogen is +2 here, is +2 here. But sulfur is -2 here. Sulfur has electron, 2 electron, and it has lose it. Sulfur has lose it. Let's see which one gains it. Chlorine is 0 here, but it's -2 here. It has gained 2 electron. 2 electron loss here, 2 electron gains here. So reduction has occurred. Redox reaction has occurred. Redox reaction has occurred. We have seen a substance that loses, and we have seen another substance that has gained. Okay, which one is oxidizing agent? Which one is reducing agent? Now, hydrogen sulfide is a reducing agent. Why is it a reducing agent? Hydrogen sulfide is a reducing agent, especially that sulfur there. Hydrogen sulfide is a reducing agent because it is the substance that loses electron. Lose. So it is the substance. Sorry, because of those that might not understand Yoruba. Hydrogen sulfide has 2 electrons to give out. So, and after giving it out, it gets oxidized. It has lose electron here. It is oxidized here, but it loses an electron to this one. So this is chlorine now is serving as oxidizing agent because it causes hydrogen sulfide to lose an electron. But at the end of the day, it is the one that gets reduced. It causes hydrogen sulfide to lose 2 electrons, then it gains that electron. When it gains that electron, it gets reduced. So this is oxidizing agent. This is oxidizing agent, and this is reducing agent. And what happened again? So this gets reduced here, and this one gets oxidized here. Are we together? So here now we can find another arrow to do that. From here to here, from here to here. What happened there? Loss of electron. Oxidation has occurred because reducing agents will get oxidized at the end of the day. Oxidation has occurred. But from here, I want the arrow from here to here, what has happened? This one is 0, it has gained. So reduction has occurred here. So there is no way oxidation will occur and reduction will not occur. So we have so many examples of oxidizing and reducing agents. We have them, but one of them is here now. At least we have no one. Reducing agent is hydrogen sulfide, and chlorine is oxidizing agents. All non-metals are oxidizing agents, and all metals are reducing agents. Let's give us some little examples of oxidizing agents. Examples, you can find them in our textbooks. Examples: all non-metals, they are oxidizing agents. All non-metals, but all these potassium permanganate, MnO4, MnO4, H2, SO4, HNO3, etc. They are all. Check your textbooks for so many examples. Or even if you don't know it and they give you a question, when you look at the equation, you analyze it. You look for the one that give out electron, the one that accept it. By that, you can say this is an oxidizing agent, because we can have a situation whereby a substance will act as oxidizing and as reducing agent at the same time. We have such. So it is better to understand the concept to know its work. Look at what a substance does in an equation. By that, you will know if that substance is an oxidizing or a reducing agent. This is where we are going to stop the class for today. Thanks for listening. Please don't forget to subscribe and like. Then you turn on your notification for our subsequent videos. Thank you. Goodbye.